Chapter 2 Whole Numbers.
Part 1.
Page 28. 2.1 Introduction. As we know, we use 1, 2, 3, 4, etc. when we begin to count. They come naturally when we start counting. Hence, mathematicians call the counting numbers as natural numbers. Predecessor and successor. Given any natural number, you can add 1 to that number and get the next number, that is, you get its successor. The successor of 16 is 16 plus 1 is equal to 17. That of 19 is 19 plus 1, which is equal to 20, and so on. The number 16 comes before 17. We say that the predecessor of 17 is 17 minus 1, which is equal to 16. The predecessor of 20 is 20 minus 1, which is equal to 19, and so on. The number 3 has a predecessor and a successor. What about 2? The successor is 3 and the predecessor is 1. Does 1 have both a successor and a predecessor? Try these. 1. Write the predecessor and successor of 19, 1997, 12,000, 49, 1 lakh. 2. Is there any natural number that has no predecessor? 3. Is there any natural number which has no successor? Is there a last natural number? We can count the number of children in our school. We can also count the number of people in a city. We can count the number of people in India. The number of people in the whole world can also be counted. We may not be able to count the number of stars in the sky or the number of hair on our heads. But if we are able, there would be a number for them also. We can then add 1 more to such a number and get a larger number. Page 29. In that case, we can even write the number of hair on 2 heads taken together. It is now perhaps obvious that there is no largest number. Apart from these questions shared above, there are many others that can come to our mind when we work with natural numbers. You can think of a few such questions and discuss them with your friends. You may not clearly know the answers to many of them. 2.2 Whole numbers. We have seen that the number 1 has no predecessor in natural numbers. To the collection of natural numbers, we add 0 as the predecessor for 1. The natural numbers along with 0 form the collection of whole numbers. In your previous classes, you have learned to perform all the basic operations like addition, subtraction, multiplication, and division on numbers. You also know how to apply them to problems. Let us try them on a number line. Before we proceed, let us find out what a number line is. Try these. 1. Are all natural numbers also whole numbers? 2. Are all whole numbers also natural numbers? 3. Which is the greatest whole number? 2.3 The number line. Draw a line. Mark a point on it. Label it 0. Mark a second point to the right of 0. Label it 1. The distance between these 2 points, labeled as 0 and 1, is called unit distance. On this line, mark a point to the right of 1 and at unit distance from 1 and label it 2. In this way, go on labeling points at unit distances as 3, 4, 5 on the line. Here we have a picture of the number line with numbers 0, 1, 2, 3, 4, 5, 6, 7 marked on it at unit distances. What is the distance between the points 2 and 4? Certainly, it is 2 units. Can you tell the distance between the points 2 and 6? Between 2 and 7? On the number line, you will see that the number 7 is on the right of 4. This number 7 is greater than 4. That is, 7 is greater than 4. The number 8 lies on the right of 6. and 8 is greater than 6. Page 30. These observations help us to say that out of any two whole numbers, the number on the right of the other number is the greater number. We can also say that whole number on left is the smaller number. For example, 4 is less than 9. Four is on the left of 9. Similarly, 12 is greater than 5. 12 is to the right of 5. What can you say about 10 and 20? Mark 30, 12, 18 on the number line. Which number is at the farthest left? Can you say from 1005 and 9756 which number would be on the right relative to the other number? Place the successor of 12 and the predecessor of 7 on the number line. Addition on the number line. Addition of whole numbers can be shown on the number line. Let us see the addition of 3 and 4. We have a number line showing numbers marked as 0, 1, 2, 3, 4, 5, 6, 7, and so on. Start from 3. Since we add 4 to this number, so we make 4 jumps to the right, from 3 to 4, 4 to 5, 5 to 6, and 6 to 7, as shown here. We have the jumps marked as arrows from 3 to 7. The tip of the last arrow in the fourth jump is at 7. The sum of 3 and 4 is 7. That is, 3 plus 4 is equal to 7. Try these. Find 4 plus 5, 2 plus 6, 3 plus 5, and 1 plus 6 using the number line. Subtraction on the number line. The subtraction of two whole numbers can also be shown on the number line. Let us find 7 minus 5. We again have a number line here with numbers marked from 0 all the way to 7. Start from 7. Since 5 is being subtracted, so move towards left with one jump of 1 unit. Make 5 such jumps. We reach the point 2. We get 7 minus 5 is equal to 2. On the number line, we have the jumps shown with the help of arrows. Try these. Find 8 minus 3, 6 minus 2, 9 minus 6 using the number line. Multiplication on the number line. We now see the multiplication of whole numbers on the number line. Let us find 4 multiplied by 3. Again, we have a number line here with numbers marked from 0 all the way to 12. Page 31. Start from 0 Move 3 units at a time to the right. Make 4 such moves. Where do you reach? You will reach 12. So we say 3 multiplied by 4 is equal to 12. Try these. Find 2 multiplied by 6, 3 multiplied by 3, 4 multiplied by 2 using the number line. Exercise 2.1. 1. Write the next 3 natural numbers after 10,999. 2. Write the 3 whole numbers occurring just before 10,001. 3. Which is the smallest whole number? 4. How many whole numbers are there between 32 and 53? 5. Write the successor of A. 2440701, B. 100199, C. 1099999, D. 2345670. 6. Write the predecessor of A. 94, B. 10000, C. 208090, D. 7654321. 7. In each of the following pairs of numbers, state which whole number is on the left of the other number on the number line. Also write them with the appropriate sign, that is, greater than or less than, between them. A. 530, 503. B. 370, 307. C. 98765, 56789. D. 9830415, 100230001. 8. Which of the following statements are true and which are false? A. 0 is the smallest natural number. B. 400 is the predecessor of 399. C. 0 is the smallest whole number. D. 600 is the successor of 599. E. All natural numbers are whole numbers. F. All whole numbers are natural numbers. G. The predecessor of a 2-digit number is never a single-digit number. H. 1 is the smallest whole number. I. The natural number 1 has no predecessor. J. The whole number 1 has no predecessor. K. The whole number 13 lies between 11 and 12. L. The whole number 0 has no predecessor. m. The successor of a two-digit number is always a two-digit number. (2.4) Properties of whole numbers. When we look into various operations on numbers closely, we notice several properties of whole numbers. These properties help us to understand the numbers better. Moreover, they make calculations under certain operations very simple. Page 32. Do this. Let each one of you in the class take any two whole numbers and add them. Is the result always a whole number? Your additions may be like this. 7 plus 8 is equal to 15, a whole number. 5 plus 5 is equal to 10, a whole number. 0 plus 15 is equal to 15, a whole number. Dash plus dash is equal to dash. Dash plus dash is equal to dash. Fill in the blank spaces with the right numbers. Try with 5 other pairs of numbers. Is the sum always a whole number? Did you find a pair of whole numbers whose sum is not a whole number? Hence, we say that sum of any two whole numbers is a whole number. That is, the collection of whole numbers is closed under addition. This property is known as the closure property for addition of whole numbers. Are the whole numbers closed under multiplication too? How will you check it? Your multiplications may be like this. 7 multiplied by 8 is equal to 56, a whole number. 5 multiplied by 5 is equal to 25, a whole number. 0 multiplied by 15 is equal to 0, a whole number. Dash multiplied by dash is equal to dash. Dash multiplied by dash is equal to dash. Fill in the blank spaces with the right numbers. The multiplication of two whole numbers is also found to be a whole number again. We say that the system of whole numbers is closed under multiplication. Closure property. Whole numbers are closed under addition and also under multiplication. Think, discuss and write. 1. The whole numbers are not closed under subtraction. Why? Your subtractions may be like this. 6 minus 2 is equal to 4, a whole number. 7 minus 8 is equal to dash, not a whole number. 5 minus 4 is equal to 1, a whole number. 3 minus 9 is equal to dash, not a whole number. Take a few examples of your own and confirm. Page 33. 2. Are the whole numbers closed under division? No. Observe the table here. 8 divided by 4 is equal to 2, a whole number. 5 divided by 7 is equal to 5 by 7, not a whole number. 12 divided by 3 is equal to 4, a whole number. 6 divided by 5 is equal to 6 by 5, not a whole number. Justify it by taking a few more examples of your own. Division by 0. Division by a number means subtracting that number repeatedly. Let us find 8 divided by 2. 8 minus 2 is equal to 6, 1. Minus 2 is equal to 4, 2. Minus 2 is equal to 2, 3. Minus 2 is equal to 0, 4. Subtract 2 again and again from 8. After how many moves did we reach 0? In 4 moves. So we write 8 divided by 2 is equal to 4. Using this, find 24 divided by 8, 16 divided by 4. Let us now try 2 divided by 0. 2 minus 0 is equal to 2. 1. Minus 0 is equal to 2. 2. Minus 0 is equal to 2. 3. Minus 0 is equal to 2. 4. In every move we get 2 again. Will this ever stop? No. We say 2 divided by 0 is not defined. Page 34. Let us try 7 divided by 0. 7 minus 0 is equal to 7. 1. Minus 0 is equal to 7. 2. Minus 0 is equal to 7. 3. Again, we never get 0 at any stage of subtraction. We say 7 divided by 0 is not defined. Check it for 5 divided by 0, 16 divided by 0. Division of a whole number by 0 is not defined.